Cambridge IGCSE 0625/42, February-March 2024, Paper 4, Theory Extended. Full paper walkthrough. Question 7. Draw a circuit symbol for a potential divider. So this is the symbol which you have to draw. You're also supposed to remember these circuit symbols. Part B. Figure 7.1 shows a circuit. Calculate the V out when the value of R is 3 kilo ohms. So in this question we have to use this equation. And that would give us 1.5 volts. Part 2. The value of R is adjusted until the current in the circuit is 1.7 milliamps. Calculate the charge that flows through the circuit in 300 seconds. Okay, we have the time, we have the current. We can use the equation. Q is equal to IT, where we know that the current is 1.7 milliamps. We are converting it to amps, multiplied by the time, which is 300 seconds. And that would give us the charge as 0.51 coulomb. Question 8. Figure 8.1 shows a wire carrying a large current. Figure 8.2 shows a squared card viewed from above. So this is a squared card and we're viewing it from above. On figure 8.2, draw 3 magnetic field lines that indicate the direction of the magnetic field and how its strength varies with the distance from the wire. So in order to find the direction of the magnetic field, we need to use a right hand rule. So when we use a right hand rule, we know that the direction is clockwise. And you have to draw magnetic field lines and show how it varies with the strength. So this is what you're supposed to do. Here you can see that this gap is much smaller than this gap, which indicates that away from the wire, the magnetic fields are weaker. The current in the wire increases and the direction of the current reverses. State how these changes affect the magnetic field. So now the current is into the page. So what the question says is the direction reverses to out of the page. So how the current changes? Initially, this direction is clockwise. When the current reverses, the direction would be anti-clockwise. So we can say that the direction of the magnetic field reverses, and we can say this magnetic field strength increases because the current in the wire increases. Part B. Electricity is transmitted at high voltage. Explain why a high voltage increases efficiency of transmission even with thinner wires. Electricity is transmitted at a high voltage because this allows the current to be low for the same power output, reducing energy loss. Power loss is given by the equation P is equal to I square R. So a lower current means much less energy is lost as heat. Even though thin wires have high resistance, lower current still keeps energy loss minimal, improving efficiency. Question 9. An experiment directs alpha particles at a very thin sheet of gold foil. Most of the alpha particle pass through the thin foil in a straight line. State the conclusion about the atoms from this observation. Most of the atom is empty. Some of the alpha particles are deflected through an angle less than 90 degrees, and a few are deflected through 180 degrees. State and explain 2 conclusions about the nuclei of atom from this observation. The first conclusion is that the nucleus is very small. The explanation is not many alpha particles pass close to the nucleus. The conclusion 2 is that the nucleus is positively charged. That's because alpha particles are positively charged, so there's a force of repulsion. A source contains a radioactive isotope of strontium. This isotope decays by the emission of beta particles. The half-life of this isotope is 29 years. State the change in the nucleus which occurs when beta particles are emitted. Neutron is changed into a proton and electron is emitted, which is the beta particle. The initial mass of this isotope of strontium in this source is 25 micrograms. Calculate the mass of strontium isotope which decays in 87 years. We know the half-life is 29 years, and calculate the mass of strontium that decays in 89 years. So we can divide 87 by 29 to find the number of half-lives, and that gives us 3 half-lives. So the initial mass is 25, and after the first half-life it would be 12.5, and then after the second half-life it would be 6.25. After the third half-life it would be 3.125. So the mass would be 3.125. Question 10. Figure 10.1 represents different positions A to H of the moon as it rotates around the Earth. State a position of the moon where an observer sees there's a quarter moon. Okay, so that's A or E. Full moon, that's at position G. So you can write any one for the quarter moon. State the approximate time taken for the moon to orbit the Earth. It's 1 month. The average distance between the Earth from the Sun is 1.5 times 10 to the power 8 kilometers. Calculate the average orbital speed of Earth in kilometers per hour. So we know the average distance, and we asked to find the orbital speed. So we can use this equation. Speed is equal to distance over time, where the distance is the circumference, which is 2 pi r. So we have to substitute it here, which gives us 2 pi r divided by the time. We know that it takes 365 days for the Earth to orbit around the Sun. So we can use that 2 times pi times 1.5 times 10 to the power 8. This gives us the hour, and that gives us the speed of light in vacuum is 3 times 10 to the power 8 meters per second. Calculate the time taken for light from Sun to reach the Earth. We can use speed is equal to distance over time. We know the distance. That gives us 500 seconds. Question 11. State the condition required for a protostar to become a stable star. Force of gravitational attraction is balanced by an outward force due to fusion reactions. Part B. Define the Hubble's constant. The Hubble's constant is defined as the ratio of speed at which the galaxy is moving away from the Earth to its distance from the Earth. The current estimate for Hubble's constant is 2.2 times 10 to the power minus 18 per second. State which equation gives the estimate of age of the universe. Calculate an estimate for the age of universe, and that gives us 4.5 times 10 to the power 17 seconds. So that's it for this paper. If you have any doubts, drop them in the comments. Thank you for watching.